All right, our lesson today is adding and subtracting rational numbers. So last lesson we learned what rational numbers are. We said rational numbers were any numbers you could turn into a fraction. So we said whole numbers because you could turn them into a fraction by putting them over 1. Fractions themselves because they already are a fraction. Decimals as long as they either terminate, which means they have an endpoint, or they're repeating, which means they have a pattern that goes on forever and ever. Integers, meaning negative whole numbers as well, because you could put those over 1, and mixed numbers. So when you have a whole number with a fraction, you could turn that into a fraction, and we talked about how you would multiply the whole number to the denominator, add the numerator, all that kind of stuff. So now we're going to be talking about how we add and subtract rational numbers, specifically fractions and decimals and integers. All right. Now we already learned how to add integers when they are like um, add and subtract integers, but we're going to talk about like when they're negative fractions and negative decimals and things like that as well. So let's first talk about fractions. When you're adding or subtracting fractions, you have to have a common denominator. All right, a denominator is the bottom part of your fraction. So the top is your numerator, the bottom is the denominator. Now, they have to be the same if you're adding or subtracting. So if I said something like um, 2/9 plus 4/9, well, we would look at the denominators and we would notice that they're already the same. So since they're already the same, we would just add the numerators. We do not add the denominators. We'd say 2 plus 4 is 6, so the top is 6, and then we keep the bottom 9. Now this is definitely review. You've learned this in probably 4th grade, definitely 5th grade, and definitely again probably in 6th grade. Now you have to simplify it if possible. So you'll notice that 6/9 you could simplify it. They're both divisible by a number, and that number would be 3. So if you divide each one by 3, you get 2/3. Now, that was pretty simple because the denominators were the same. Let's talk about when the denominators are not the same. So if I had something like 1/3 plus 2/5, you'll notice that the denominators this time are different. So the way we're going to actually solve this is we have to find a common denominator. All right, what that means is we need to come up with a denominator that I could turn both of those into by multiplying by something. Now we want it to be the smallest possible one, which is called the least common denominator, the LCD, the smallest. All right, so if you think about it, you should notice that I could turn both of those denominators into 15 by multiplying by something. That's the smallest number you could turn them both into. All right, so the way we're going to do that, we're going to look at this denominator of 3, and we're going to say what times 3 gives me 15, because the new denominator is going to be 15. We keep the plus sign. So we know that 3 times 5 is 15, but if I multiplied by 5 on the bottom, I have to multiply by 5 on the top. So 1 times 5 gives me 5. And then over here, this 5, you would multiply times 3 to get 15. So you multiply the top by 3 as well. 2 times 3 is 6. And now the denominators are the same. Now I could add the numerator. So 5 plus 6 is going to be 11 out of 15. And you would have to simplify this if possible. However, this is not possible to simplify. That's already in simplest form. 11/15 would be your answer there. All right. I'm going to give you one to try. Let's see. What about this one? Sorry, I'm looking for a really good one. All right. What about All right, pause it, try it, and we'll talk about it. All right, now that you've paused it and tried it, let's work on it together. So if you look at the denominators, they're not the same right now. Now, I'm always looking for the least common denominator, okay? So if I look at those two numbers, the least common denominator there, the smallest number, the smallest multiple that they have in common would be 8, okay? If I make them both an 8, well, this first one, the first problem that says 3/8, the 8 here, if I multiply that by 1, it stays 8, which is good. If I do that to the bottom, I have to do that to the top. So 3 times 1 is 3. So that first fraction just stays the same, 3/8. Now this 4, I'd have to multiply by 2, which means I have to multiply the top by 2. So 1 times 2 is 2. So I get 3/8 plus 2/8, which is 5/8. So you get 5/8. Let's throw some negatives in there now. All right. So if I said something like negative 3/4 plus negative 1/2, I'm going to do the exact same thing. I'm going to find a common denominator. Right now you can see that they're not the same. I have a 4 and a 2. So I know that the common denominator there, the least common denominator would be 4. I want to turn them both into 4. It says plus there. All right, so the 4 here in the first one stays a 4, which means the top stays negative 3. This 2 over here, to turn it into a 4, I have to multiply by 2, which means I need to multiply the top by 2. Be careful with your integers. Negative 1 times positive 2 gives you negative 2. So I have negative 3/4 plus negative 2/4. Now the denominators are the same, but be careful. Now we have to make sure we're thinking about our integers. We know the denominator is going to be 4, but let's look at the numerator. It's negative 3 plus negative 2. We have to follow the same rules that we've followed every other time when we've added integers. Oops. Sorry. All right, so we're going to look at this first number of negative 3, which is negative, and this negative 2, which is also negative. So when both of the signs are negative, we add them, or well, let me rephrase that. When both of the signs are the same, we add them. 3 plus 2 is 5, and keep the sign. So you get negative 5/4. However, that's an improper fraction. We have to turn that into a mixed number. So we're going to say, how many times does 4 go into 5? Well, it goes in there one whole time, and then there's 1 left over out of, keep the denominator the same, 4, but don't forget that it was negative. So my answer is negative 1 1/4. All right, I'm going to let you guys try one now. How about one like this. Negative 1/3 minus negative 5/6. Pause it, try it, and we'll talk about it. All right, now that you've tried it, let's talk about it. So right away, before we do anything, I hope you notice the two negative signs sitting next to each other. When you have those two negative signs, it turns into a plus. We're still following all the same rules that we learned before about integers. So I have a negative 1/3 plus a 5/6, right? So the denominators are not the same, so we have to find a common denominator. My common denominator would be, well, I'm going to say 6, right? So 3 times 2 is going to give me 6. Multiply the top by 2. I have a negative 1 times 2, which is negative 2. And then here, the 6, I don't have to multiply, I just multiply by 1. And then it means I multiply the top by 1. So 5 times 1 is 5, 6 times 1 is 6. Now the denominators are the same. That says plus. Now, I know it says plus, but again, we have to follow integer rules. So I know the denominator stays a 6, but the numerators now say negative 2 plus 5. So I have to look at the value of each number. The 2 is negative. The 5, however, is positive. They're different signs. When they're different signs, we subtract them and keep the sign of the bigger number. 5 is bigger than 2, and it's positive. So I get 3/6. However, I have to simplify that. They're both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So you get 1/2 as your final answer there. All right. What if you had 3 fractions being added or subtracted together? Something like, let's see. 1/9 plus 3/5 plus, no, let's do minus 4/15. All right, so we do the same thing. We're going to look at the denominators. They're all different. We have to have all 3 the same. So it might not come to you right away, but the least common denominator here would be 45. So if I make these all out of 45, let's think about this. All right, 9 times what is 45? Well, 9 times 5 is, and then 1 times 5 would give me 5. All right, now this is a positive 3/5, so, and it says plus, so I'll keep it like that. 5 times what gives me 45? Well, 5 times 9, which means I multiply the top by 9 as well. So 9 times 3 is 27. Okay, and then lastly, it says minus 4/5. So don't put, I'm going to put the minus sign, which really means that this fraction itself is negative. So 15 times what gives me 45? Well, 15 times 3 gives me 45. And then 4 times 3 is going to give me 12. So I have 5/45 plus 27/45 minus 12/45. All right. So I know my final answer that 45 will be the denominator, but I have to worry about the numerators. It says 5 plus 27 minus 12. So the 5 here is positive. The 27 is also positive. I'll look at that negative 12 in a minute. So they're the same sign, so I'm going to add them, and I get 32 and keep it positive, right? And then I have this minus 12, which means the 12 itself is negative, right? So the 32 is positive, right? But the 12 is actually negative because there's a minus sign in front of it, which means that the 12 is actually a negative number. So they're different signs, right? When they're different signs, we're going to subtract them. So 32 minus 12 is going to give me 20, and then keep the sign of the bigger number. Well, 32 is bigger than 12, and it's positive, so you get positive 20 over 45. The only thing is you'd have to simplify if possible, which in this case, they're both divisible by 5. So if we divide each one by 5, 20 divided by 5 is going to be 4. 45 divided by 5 is going to be 9. So your final answer would be 4/9 here. All right, let's talk about mixed numbers. All right, mixed numbers, it's similar, but a little bit different. So let's talk about how that works. If I said something like 3 1/4 minus 2 actually, let's make this plus 2 3/5. No, I'm going to change that. Let's make that 3/8. Okay. Now, when you're adding mixed numbers, I'm going to tell you, you could easily, like when they're both the same sign, which means you're going to be adding them, you could just add the whole numbers. 3 and 2 is going to give you a 5. And then I'll take the fractions and I'll do add those together. I have 1/4 plus 3/8. 1/4 plus 3/8, the denominators are not the same. So I'm going to find a common denominator, which would be 8. 4 times 2 gives you 8. So multiply the top by 2 and you get 2 times 1, which is 2. 8 times 1 gives you 8. Multiply the top by 1 as well. So 3 times 1 is 3. So I have 2/8 plus 3/8, which is going to be 5/8. So we would now take that 5/8 and bring that up and attach it to the whole number. So you get 5 and 5/8 as your answer. So when you're adding, which means the signs are the same, you're just going to add the two numbers, the whole numbers together, and then add the fractions. Now, when the signs are different, then you have to do a little bit more work. So if I said something like 6 and 2/3 minus 4 and 5/6. All right, when you can see the signs are different. Here it's positive and the 4 and 5/6 is actually negative. So when the signs are different, which means you're going to actually technically be subtracting, you have to turn these into improper fractions. So I'm going to say 6 times 3 is 18 plus 2 is going to be 20, and then keep the denominator out of 3. And then that says that minus sign, and then 4 times 6 is 24, plus 5 is 29 over 6. So far, we're on the right track. Now, though, the denominators are not the same. So I have to find a common denominator. So the common denominator is going to be 6. 3 times 2 gives me 6. Multiply the top by 2. 20 times 2 is going to give me 40. Then the 6 times 1 keeps it 6, and then multiply that by 1. That's technically a negative 29 times 1, so that turns into a negative 29, which is like a minus sign. So the denominator is going to be 6, and now I'm going to say 40 and a negative 29, which is 40. It looks like 40 minus 29, which it is. The 40 is positive, the 29 is negative, so they're different signs. I'm going to subtract them, and I'm going to get 11, positive, because the 40 is bigger. So I have positive 11. So positive 11 over 6, which I now need to turn into a mixed number, because that's not a proper fraction. 6 goes into 11 one whole time, and then there's 5 left over, and then keep the denominator out of 6. So your final answer would be 1 and 5/6. All right, I'm going to let you guys try the next one. All right, I want you to try this one, and then we'll talk about it. So pause it, okay? All right, now that you've tried it, let's talk about it. I know it says plus. However, you should notice the signs are different. This one's a negative, this one's a positive. So when they're different signs, you're actually subtracting them. So I told you that if the signs are different, you actually have to turn them into mixed or improper fractions. If the signs are both the same, then you could just add the numerator or add the whole numbers and then do the fractions separately and then combine the answers together. But when they're different signs, we have to turn them into mixed numbers. So 9 times 5 is 45, plus 4 is going to be 49. So I have 49 over 5, but this whole thing is negative, so I have to put the negative sign in front. Now 2 times 4 is 8. 8 plus 3 is 11 out of 4, and it's positive, so I'll keep it a plus sign. Now the denominators are not the same. We need to turn them into common denominators. So the common denominator here would be 20. Oops. All right, so 5 times 4 is 20. I have to multiply the top by 4, which it's a little weird. 49 times 4, well, I know 50 times 4 is going to be 200, so that makes it 196, I believe. 49 times 4, yeah, it's going to be 196, but it was a negative 49, so 4 times negative 49 makes that a negative 196. All right, and then 4 here, multiply that by 5 to get 20, and multiply that by 5, so 11 times 5 is 55. So the denominator is going to be 20, right? But the numerator, it says negative 196 plus 55. So the negative 196, that's a negative, and then the 55 is a positive. They're different signs, so I'm going to subtract them. So I'm going to get, I believe, 141 when I subtract 196 minus 55. Yeah, that sounds right. And then the negative 196 is bigger. So that means that the 141 is actually a negative. Now the last thing I need to do is turn that into a mixed number. So 20 goes into 141. Well, 20 goes into, I believe, 7. Yeah, 20 goes into 141 7 times. There's 1 left over, and then keep the denominator at 20, but don't forget your whole answer is negative. So negative 7 and 1/20. All right? All right, let's talk about decimals now. So decimals, when we're adding and subtracting decimals, you must line up the decimals. All right, so if I said, let's see, 2.5 plus 74. All right, so this is where place value comes in. Okay, we need to know our place value. So right now, this 2.5, 2 is in the ones place, 5 is in the tenths with a th, tenths place. This 74, the 7 is in the tens place and the 4 is in the ones place. So they're both positive. We're going to look at the sign of each number. They're both positive. So if they're both positive or they're both the same sign, we're just going to add them. But we have to line up the decimals. So 2.5, I'm actually going to put the 74 first. And then the 2.5, this 4 is in the ones place and this 2 is in the ones place. So the 2 has to line up with the 4 because they're both in the ones place. Now that 0.5 is behind it. And if there is no decimal in the 74, and again, I know you've learned this, so you just put a decimal and you could add a 0. 74.0 is the same as 74. Please don't add 74 plus 2.5 like that. That's not right. You need to line up your decimals. So 74.0 plus 2.5. So I lined up my decimals. 5 plus 0 is 5. Put my decimal there where it goes in the problem, right? And then I say 4 plus 2 is 6, and then the 7, there's nothing to add it to, so I get 76.5, and they're both positive, so your answer is positive. Now, just be careful when we're talking about integers. So if I said, let's see, negative 1.5 plus 0.2. All right. So right now, this 1 is in the, first of all, let's realize that they're different signs, right? The 1.5 is negative and the 0.2 is positive. So when they're different signs, I'm really subtracting them, right? So if I'm subtracting them, I'm going to do the 1.5 minus the 0.2. Now be careful. The 1.5, the 1 is in the ones place and the 5 is in the tenths place. This 0.2, the 2 is in the tenths place, so the 2 has to go right underneath the 5 with the decimal, which since there's no number in front of the decimal, you can put a 0 there, and we're subtracting because they are different signs. So 5 minus 2 is 3, 1 minus 0 is 1, so I get 1.3, put your decimal right where it was, right? However, we have to look at the numbers. 1.5 is bigger than 0.2. That's not 2, it's 0.2. Okay, that's in the tenths place. This is over 1. This is less than 1. This is bigger than 1. So the 1.5 is bigger, and it was negative, which means your final answer would be negative 1.3. All right, I'm going to let you guys try one now. All right. negative 12.4 plus 9.2. Try it and we will talk about it. All right, now that you've talked about it or you've tried it, let's talk about it. So they're different signs. This is a negative and this is a positive. So when they're different signs, we subtract. So we'll take the number that has a bigger absolute value, which is the 12.4, and subtract the 9.2. Now, this 12.4, we have a 1 in the tens place, a 2 in the ones place, and a 4 in the tenths place. On this number, the 9 is in the ones place, and the 2 is in the tenths place. So the 9 goes over underneath the 2 because those are both in the ones, and then the 0.2 goes underneath the 4 because those are both in the tenths with the th, tenths. So I'm going to subtract them. My decimal goes there. 12 minus 9 is going to give me 3. But then the 12.4 is bigger than the 9.2 and it's negative, so you get negative 3.2 is your answer. I'm going to try one or two more and then we're pretty much done. All right, what about this one? Negative 0.5 minus 3.7. Okay, pause it and try it, and then we'll talk about it. All right, so now that you've tried it, let's do it. So this 0.5 is negative, right? 0.5 is a negative. This 3.7 is also negative. So they're the same sign. When they're the same sign, what are we doing? Well, we're going to add them this time. So we're going to say now that 5 is in the tenths place, the 3 is in the ones place, the 7 is in the tenths place. So 0.5, and we're going to add 3.7. So the 0 here is in the ones place, and the 3 here is also in the ones place, and then that 7 is in the tenths place. So we're going to add like this. So 5 plus 7 is going to give me 12. And then I have 1 plus 0 plus 3, which is 4. Bring my decimal straight down. So I get 4.2, but they were both negative. So when they're the same sign, you add them and keep the sign. So you should get negative 4.2. All right, and that's pretty much the lesson. Please make sure you're lining up your decimals really well. If I said something like 432.98 plus 0.06, all right, be careful. When you add them, we're going to say 432.98. That 6 is in the hundredths or tenths. No, I'm sorry, hundredths place. So you have to, here the 9 is in the tenths, the 8 is in the hundredths. So that 6 is also in the hundredths. So the 6 goes there, the 0 goes there, and then the decimals line up. All right? And you would add it like that. Just make sure you're aligning your decimals properly. All right? One more thing. If I said something like 328 minus 2.05. All right, the 328 is positive and the negative, or the 2.05 is negative. So they're different signs, so I'm going to subtract them. But I'm not going to do that. The decimals are not lined up right now. Technically, if there is no decimal in 328, the decimal is at the end, right? Okay, so I have to line my decimals up. So right in front of the decimal was a 2, and then behind it was 0.5. So I could add 2 zeros at the end, and now I could subtract. And I'd have to borrow, which we'll do really quick. I can't borrow from here, so I borrow from here, and I make that a 7. This turns into a 10, which then turns into a 9. Hopefully you remember how to subtract and borrowing and everything. 10 minus 5, 9. 7 minus 2 is going to be 5. And then which one's bigger? Well, 328 is bigger than 2.05 and it's positive. So your answer would be positive 325.95. All right, so a lot of review stuff mixed with stuff we've learned before. So you kind of already knew how to add and subtract fractions and decimals. Maybe you didn't remember completely, but this was a good review. The only thing different now is that we're throwing in negatives and you have to use the same rules. So that's our lesson. Make sure you're doing the assignment that goes with it, and letting me know if you have any questions. All right? All right.